So in this video, let's take a look at how routing is used on computer networks. So in this first example, we're just going to examine a typical home network. So this is likely what your network looks like in your house. And the very first device on your network is going to be a modem. And so this is the one that's connected to the cable. I just call it internet right now, but this is the one that's going out of your house to your internet service provider. And then the first device connected to the modem, and the modem is typically given to you by your internet service provider. And so your modem is connected to your router, and the router is then connected to all of the other devices on your network at home. So there's some Ethernet ports on the back of this. So I have a desktop computer, and I'm trying to show that as connected to the router directly by a wire. And then you can see the antennas on my router. So here are all of my devices on my home network that might be connected by Wi-Fi. So got a couple laptops and a printer, some phones, maybe a smart TV. We could have other devices on the network like the doorbells with the cameras in them, security cameras, smart thermostats, things like that. All of that would be connected to your router. So let's look a little bit closer at this part, because I think unless you set up your home network yourself, these are not devices that you think about regularly. So I'm going to expand the picture. This is what's really going on with your modem connection. And so the modem is connected to, there's some wires that the cable company or phone company sends into your house, and there's going to be some boxes like this on the side of your house, and the wires run through your house, and somewhere there's going to be a jack, and you plug your modem up to that. And then the wire will go down underground, and it's probably going to go out to some box in your yard or a neighbor's yard, and maybe several houses will all have their cable and phone go into boxes like this out in the front yard. So the problem is, just with a lot of construction, is the cable that runs from the box out in your yard to your house, or the cabling that's running through your house, might not be capable of carrying digital signals the same way the wiring in a computer network might. So the purpose of the modem is to take that digital data from inside your computer network and turn it into a transmission that can go on typical cable you might find outside, like coaxial cable or telephone lines. And the purpose of the router is to forward data packets between devices on your network, or from one computer network to another. And you'll see that in a second, how this works. So going back to our network inside, now that we have devices that are need to communicate with each other, they need a way to identify themselves. So every device on the network is going to be given something called an IP address. And an IP address is just a numeric identifier for the devices. And these are kind of the IP addresses you'll see. So your modem is going to have an IP address, and your router will have an IP address. And then each time you connect a device with Wi-Fi or plug it into the Ethernet, it will get an IP address as well. So these IP addresses are how the devices are going to find each other on the network. So one thing that might happen here, I have the desktop printer wanting to print something, or the desktop computer wanting to print something. So the desktop computer will not communicate with the printer directly. Instead, it will send a message to the router saying, hey, I would like to send this information to the device at the address 10.0.0.4. And the router will go, I know where that address is, and that's one of my Wi-Fi devices. So I will use my antenna and I will send a signal out here. And all of these devices are listening, but the printer will go, yep, that's the message intended for me, and it'll start printing. If you were using your phone to maybe cast something to your smart television, right? So what you would do is you would send the request for your television to cast something to the router, and the router would go, oh, I know the IP address of your TV, and it's going to send that request over here. And then the TV will get that request, and it will go, oh, wait a minute, I know I know how to get that show, and it sends a signal back to your router, and the router goes, that show's out on the internet, right? And then that's how you get your television show. And then just a normal laptop trying to communicate with or to maybe view a web page, right? It'll send the request to the router, and this router will look at the IP address of the website. So this computer knows the IP address of the website, and it will say, well, that IP address is not on my network, so I will send it out this direction. Right. So why do we set up our home networks like this? Mainly because it's really easy to do and really cheap, right? You have two devices to plug in. You might not even have anything wired on your home network. And then, once you plug these devices in, it's a matter of knowing the password to this, and you log in and everything's hooked up and everything works. So really easy to set up, really inexpensive. A router might be, $50 to $100. And one last little advantage of setting up a network like this, with the router being like the very first thing kind of that you own on your network, is that it will add some security to your network. So if you're trying to block malicious traffic from getting to your devices, it can be blocked at the router level, and you don't have to, so you can tell the router just not to let certain traffic through, and you don't have to worry about making sure that every single device is configured to avoid certain sources of maybe malicious traffic. And one little disadvantage with this is if the router goes down, then the entire network is completely down. There's no internet and there's no communication between devices. And I think we've all been in this situation, right? The network goes down, you call the cable company, and they basically tell you to go to your router and turn it off and on again. Usually that actually fixes the problem. All right, so let's look at a slightly more complicated network. So now I've got a network made up of sub-networks. And I don't have wireless routers this time either, but so I've got 4 different routers, and in this bottom 3 sub-networks, right, these are all devices plugged directly into that router. So how might devices communicate on this network? Well, a simple thing that could happen is, let's say this desktop computer wants to print in its own subnetwork. So what could happen is it will know the IP address of the printer, and it will send the data along with the IP address of the printer to its router. And the router would go, oh, I know that IP address. It's plugged into this particular outlet in the back outlet, and I'll send the data, the print job, down this cable, and so then the printing will happen. Let's suppose we want to communicate across the network. So this network might be something like, this could be like a school or an office or something like that, where, this is a wing of the school, and this is maybe the main router in the school where the internet comes in, and this is another wing of the school. So let's say these 2 computers need to communicate. What will happen is, again, this computer will know the IP address of this computer, and it will send the data this way. This router will look at the IP address and go, well, that is not one of mine. So I'll just pass it along to the next router and hope it knows where that is. Now this router, the main router, it's going to have some extra information, right? It may not know exactly where the destination computer is, but it could know like a range of IP addresses that are assigned to this router. It could know a range of IP addresses that are assigned to this router and a range assigned to this router. And so it'll look at that data and look at the IP address and go, well, that IP address is in the range that's over here, so let me send it off. And this router will then look at the IP address and go, oh, I know that, that's one of mine, and send the data down the appropriate cable. And lastly, if we want to go out on the internet, so the computer will send the request with the IP address of the website here, and it's going to go, that's not on my network, pass it along. And this one's going to go, that IP address is not in the range of any of my subnetworks, so let's send it out onto the actual internet. And then once it's out here on the actual internet, it will eventually find a router that knows where that website is hosted, and the data will come back. All right, so on subnetworks, all right, one of the things that's interesting is that each router only needs to know the devices that are connected directly to itself. And if a router needs to forward data to an IP address that it doesn't know, then all it will do is pass it along to another router, and that will continue until that request gets to a router that knows specifically where that computer is. And it's a little bit more complicated than that, but we can get into that in another video. All right. So one last network, and this time it's quite a bit more complex. And so I've introduced redundancy, and by that I mean each router is connected to multiple other routers. So again, let's look at how communication might occur. Right? On this one, let's say these two computers want to communicate. So the obvious way to do this is this computer sends a message to here, and the router looks at the IP address and says, oh, I know what router is connected to those IP addresses, and the shortest path is this way, so it sends it along. And this router says, yep, that's one of my IP addresses, and sends the data down the appropriate wire. But what if there's a fault? Okay, so let's say this wire is unavailable for some reason. Either there's damage to the wire or it's just busy with other transmission. It's no problem, because now the data can just, this router will look at a path that's no longer available and go, no problem, I'll just send it a different way. And this router will go, well, that's not one of mine, and pass it along. And eventually the data will get to a router that knows exactly where that specific computer is. And if you have enough routers and enough connections, you can tolerate a lot of problems with the network. So here I took out 2 different wires, and all of the data can, the data on any part of this network can still get to any other part of the network. So one last thing that might happen is, rather than have a path breakage, we could actually have a router go down. And in this case, it's slightly more problematic, because these 4 computers here now, devices, are completely cut off from the rest of the network and even from each other. But you can see that the rest of the network, every computer is still connected to every other computer. So why do we have redundancy on a network? Redundancy increases the reliability of the network in the case of a device or a path failure. And one of the things we could say about a redundant network is that they are fault tolerant. So you might be wondering, it's like, can this get bigger? Can we scale this up to have even a bigger network that is still very, very reliable? And as a matter of fact, we can. So this map here is all of the main internet fiber cables running across the country, running across the United States. And so you can see it's the same concept, just on a very, very large scale, with the routers and multiple paths. So let's say you wanted to communicate from New York City all the way over to Los Angeles. You'll send the data will start going down a wire, and it's going to try to take the quickest way to get there. And maybe it gets here and the quickest path is blocked. It's like, no problem, I can go this way and come around, or I can go this way and come around. And so this is, if any main line breaks on the internet in the United States, it really will have very little effect on the network as a whole, because all of the data traveling around can just take an alternate path. And believe it or not, too, like, from New York all the way to Los Angeles, you're dealing with all of that traveling and all of that decision making that happens along the way. That is going to take maybe 40 or 50 milliseconds. So we're dealing with just a tiny, tiny fraction of a second for all of that to happen. So can this get even bigger? Absolutely. And here is a map of all of the undersea cables that connect the continents and get the internet from one continent to another. And you can see that the exact same continent or concept is illustrated here, that there is redundancy. And so if a connection between continents breaks, it's in most cases not a problem, because there are multiple other connections There are a few places like small islands and stuff like that that actually only have one cable connecting them, so they could be cut off completely from the rest of the internet if there was a failure. But for a good bit of the world, there is plenty of redundancy. So thank you very much for watching, and I will talk to you in the next video.